Right, let's focus on C6, which is electrolysis. This is quite a complex chapter, so I'm going to try and break down some of the more basic stuff first. So electrolysis, the word itself, electro means to do with electricity, and then the lysis means to break down. So it's basically using electricity to break down some substances. So that's essentially what we're doing. Now, a typical electrolysis diagram would have a beaker with a solution. The solution is known as the electrolyte. You've got the electrode, which is the generic name for the these two items that was usually made of graphite. So these are the electrode. Now, depending on which is the positive and which is the negative will determine the actual specific name. So you've got the positive electrode, which is known as the anode, and the negative electrode, which is known as the cathode. You need to be able to label that and name that. And then the solution, I said, is electrolyte. And then these are usually made of graphite, like I said, but the reason why they're made of graphite is quite cheap, and also it's inert, so it's generally very unreactive. So that's why they are made of graphite. So that's your basic idea of what a diagram will look like. And then what you need to start thinking about is what are you going to separate, so the substance itself. Complex than just looking at molten solution. Molten substance. Now, if it's a less reactive metal, say you've got copper, you'll get Cu2 plus, say it's copper chloride, Cl minus, H plus, and OH minus, because it's an aqueous solution. Okay, in this case, because copper is less reactive, the actual electrolysis will be quite similar to the molten, because these ions don't get involved because of the reactivity of copper and chlorine. They're quite low in reactivity, and therefore they end up getting discharged at the electrode. So depending on which type of metal we are electrolyzing will determine what are the products you make from the electrolysis. With the less reactive metal, you'll get copper being made and chlorine. And with the more reactive metal, you'll end up making hydrogen instead of sodium, because sodium is more reactive, and you'll end up making chlorine, because chlorine is less reactive than the hydroxide ion. So this is when it starts to get a bit more complex. We'll talk about that as a bit later.